Okay, so this is going to be a video about how I feel like goalposts are being moved and about how I feel like they're debunking their own claims. So, first of all, well, I'd like to say I'm sorry for my voice. I have actually caught my daughter's cold, unfortunately. But yeah. So basically, this person here, which is basically everyone up until now, has been telling me that different density liquids mix when you drop them. You know, you accelerate them down and they will mix. The density tower will collapse. Now I've proved that wrong twice. Now they're trying to say that actually, no, you have to mix it first and then accelerate it down, and then they won't separate. Okay. So obviously that person there at the top says, not sure how this addresses the issue of different density liquids mixing in an aircraft at 0G. So again, person saying it's mixing. Mark Jones, you still haven't explained why different density liquids mix on a 0G plane. So again, and then it's like, whilst the plane is in free fall, whilst the plane is falling, which is why the different densities mix. Buoyancy is caused by G. So he's basically trying to tell me that, you know, the different densities mix. Buoyancy is caused by G. What is G? 9.81 meters per second squared. Okay. So if you drop something or something's falling, is that not G? Is that not gravity? Is that not G being shown according to most people? Yeah? Yeah. So you didn't get rid of G, did you? So you didn't get rid of buoyancy. You still have the density of the medium. You still have the acceleration rate. And you still have the volume. So you didn't get rid of buoyancy, and you didn't get rid of G, you didn't neutralise G or anything. G's still there. You accelerated at the rate of G, so you didn't get rid of G. G is the acceleration rate, right? That's what you all tell me. G is 9.81 meters per second squared downwards rate of acceleration. So yeah, you didn't get rid of G. You've literally incorporated G, you've literally let it happen. You're literally accelerating at that rate, right? So how did you get rid of G? So I says to him, so you're saying freefall makes densities mix. They're less dense on top of a more dense mix. Yes, different density liquids mix. I put, oh yeah, I saw it because he asked me whether I seen the video. I said, oh yeah, I seen it. Just make sure that's what you thought, that density towers are falling, they mix. When density towers are falling, they mix. So yeah. And then you got, like now, people are saying, actually, it would be more accurate to say that it would stop them from separating into layers rather than making them mix. So a few people have said this now after my videos showing that they didn't mix. That actually you have to mix it first and then accelerate it. So then it won't separate. So you mix it, you accelerate it, and it won't separate. That's what they're now telling me, or they now think will happen, because even though before it was, you know, you accelerate it down and it won't stay separated, it will mix, it will collapse. Now it's, you have to mix it and it won't separate. So yeah, I feel like goalposts are being moved, and I feel like they debunk their own claim again with that by saying now, you know, you have to mix it and then accelerate it and then it won't separate. They've debunked their own claim with that, because like they say, you know, that they separate because of G, this downwards acceleration, this gravity, and then they say, you know, when you accelerate down at G, that they won't separate, and yet they say the reason that we have relative density and the reason that relative density works is because of G. So you still have G, you're falling and accelerating at the rate of G, so why did relative density, or why does relative density not work if you feel like that's what causes relative density, but then you feel like it won't mix, it won't separate when it's mixing and falling? Like, you're accelerating, and again it debunks your claim. Everybody tells me all the time, acceleration causes a gradient, acceleration causes a gradient, acceleration causes a gradient. Okay, well, you're accelerating, why do you expect it not to separate? Why do you expect it not to form a gradient now? Didn't you say acceleration causes a gradient? How many times have I heard acceleration causes a gradient, acceleration causes a gradient, acceleration causes a gradient, no acceleration, no gradient, acceleration causes a gradient? Okay, well, you're dropping something, it's accelerating. Why do you now expect it not to cause a gradient? Why are you now changing your mind? Why are you now debunking yourself? Acceleration causes a gradient. Okay, it's accelerating. So why do you now not think a gradient will fall? Do you know what I mean? So yeah, just, yeah, it baffles me. Anyway, take care and stay safe.